Good morning students. Today we are going to learn the new topic today, homogeneous differential equations. So what is meant by homogeneous differential equations? If RHS is 0, the right hand side is 0, then we say the differential equation is homogeneous. If right hand side is not equal to 0, then we say the differential equation is non-homogeneous. Are getting a differential equation? If a right hand side is 0, then we say it is a homogeneous differential equation. If right hand side is a constant or some function of x, then we say it is non-homogeneous differential equation. So let us learn today homogeneous differential equations. Are you able to get it? So we are going to start a new topic today, that is homogeneous differential equations. So this is the general form. So what is that I given? You see, a into d square y by dx square plus b into dy by dx plus cy is equal to 0. So what is the order of this differential equation? Dy by dx is a first order derivative, d square y by dx square is a second order derivative. So since second order derivative exists in this differential equation, therefore the order of differential equation is 2. So this is a second order differential equation. Yes, the first thing I want to tell here is this is, since d square y by dx square is there in the equation, therefore this equation is second order differential equation. And right hand side, what is the right hand side? It is 0. As right hand side is 0, it is a homogeneous differential equation. So up to now what I saying, it is a homogeneous and it is a second order. It is a homogeneous and it is a second order. Now what about the coefficients? The coefficients are, here it is a constant, b constant, c constant. So the coefficients are a, b, c, which are constants. Therefore what about this equation is homogeneous second order differential equation with constant coefficients. Are you getting? This is, what is this? This is a differential equation which is homogeneous. Therefore homogeneous differential equation of order second order with constant coefficients. And one more point I am saying, what is the y power? Y power is 1. Y power 1 means it is linear. It is linear. So altogether what we can say about this? What we can say about this? This is homogeneous second order linear differential equation with constant coefficient. Are you able to get it, students? Right hand side 0, homogeneous d square y by dx square term is there, therefore it is second order, y power 1, therefore it is linear, and coefficients are constants. Therefore what we can say, this is a general form to which equation? Homogeneous second order linear differential equation with constant coefficients. Are you getting? So this is the general form of homogeneous second order. Now put capital D is equal to d by dx, and capital D square is d square by dx square. D cube by dx cube, third order. D power of capital D power of 4, d power of 4 by dx to the power of 4. So now substitute in a general form, what will you get? A into d square y plus b into dy plus cy is equal to 0. You can take y common. A d square plus bd plus c of y is equal to 0. This is an operator form of what? Homogeneous second order linear differential equation with constant coefficients. In shortcut I am saying every time homogeneous. That's it. Homogeneous and non-homogeneous. Homogeneous means what is that? It is a homogeneous, it is a second order, it is a linear and with constant coefficients. So every time I won't tell all this lengthy statement that it is a homogeneous second order linear differential equation with the constant coefficients. Just I simply says homogeneous. So this is a general form of, this is an operator form of homogeneous differential equation of second order, and this is a general form of homogeneous second order linear differential equation. Are you able to get it, guys? Are you able to get it? So today we are going to start how to solve homogeneous differential equation. We are going to learn today. So before that, I am giving the in first slide, and what I am giving is the general form. General form of homogeneous second order linear differential equation with constant coefficients is a into d square y by dx square plus b into dy by dx plus cy is equal to 0. And whereas the operator form, capital D is an operator, it is capital D is equal to d by dx. So a into capital D square plus b into capital D plus c of y is equal to 0 is our operator form of homogeneous second order linear differential equation with constant coefficients. Repeatedly, why I am telling you should know that. You should know that. So that's why I am repeatedly telling you. So by the seeing the equation itself, we can tell it is a homogeneous, it is a second order, it is a linear and with constant coefficients. That is so two things we given, general form and operator form of homogeneous second order linear differential equation with constant coefficients. So this is my general form and operator form of the homogeneous differential equations. Are you getting, guys? So let us see now what is an axillary equation means. Now axillary equation, axillary, A is first letter capital A, equation capital E. So in short we say A dot E. A doesn't mean assistant engineer, it is axillary equation. Okay. So A, what is axillary equation? Now consider the general form of the homogeneous differential equation. What is that general form? A into d square y by dx square plus b into dy by dx plus c into y is equal to 0. Right hand side 0. Homogeneous d square y by dx square term. The second order. Now y power 1, therefore linear. The coefficients a, b, c are constants, therefore it is a homogeneous second order linear differential equation with constant coefficients. Are you getting? So we took general form. So now let us write an operator form. So what is an operator form? What is an operator form? S. Operator form is put d by dx is equal to capital D and d square y by dx square is equal to capital D square. The D, capital D is an operator. What is a D? D is d by dx. D square is d square by dx square. D cube is d cube by dx cube. That is our operator. Now substitute that operator. What you get? A into d square plus bd plus c of y is equal to 0. This is our operator form. In previous slide only we explained. So what we got? From a general form you can always write an operator form. So in examinations we are going to use that. That's why I am clearly telling here itself. In a problem solving we are going to use this. If a general form is given, you can write an operator form from that directly. Are you getting? AD square plus BD plus C of Y is equal to 0. This is an operator form. You know general form to operator form. In operator form, what is an operator? D. At place of capital D, put M. So what will get? AM square plus BM plus C of Y, remove the Y. So AM square plus BM plus C is equal to 0 is called axillary equation. Are you getting? Very simple thing I am telling. What is an axillary equation? Take a second order homogeneous linear differential equation with constant coefficients. Then write in operator form. Once you write in operator form, at place of an operator D, capital D, write M and remove Y. So we get AM square plus BM plus C is equal to 0. That is our auxiliary equation. This is our auxiliary equation. AM square plus BM plus C is equal to 0. So once a general form or an operator form of a given differential equation is given, that is homogeneous second order linear differential equation with constant coefficient, the general form or an operator form is given, then directly from that you can write AE, that is auxiliary equation. AM square plus BM plus C is equal to 0, where the degree of M is 2, therefore it is quadratic equation in M. So AM square plus BM plus C is equal to 0 is a quadratic equation. Quadratic equation. Quadratic equation means it has two roots. Depending on the roots, we can write the general solution of homogeneous differential equation. So what are the possibility of roots? Roots may be real and distinct. Roots may be real and equal. Roots may be complex roots. Roots may be surd roots. So depending on the roots, we can write a general solution for homogeneous differential equation. That is the main point of the topic here. So given a general form of homogeneous differential equation, from that you can write operator form. From operator form you can write auxiliary equation. Auxiliary equation is nothing but quadratic equation. So you will get two roots. Depending on the roots, after finding the roots, we can write general solution. Whether roots are real and different, real and equal, complex or surd roots, depending on the roots, types of roots, you can write the general solution of homogeneous differential equation. Are you getting? This is what we are going to store. General form, then we can write operator form. From operator form you can write auxiliary equation. Once we get auxiliary equation, you can find roots. By finding the roots, then we can write general solution. So how you can write general solution after finding the roots? That's what we are going to learn now. Now that is an important slide that we are going to move. Yes, let us move to, so what are the roots and then what is the solution? So this is an important slide of the class. To solve the equation a d square y by dx square plus b into dy by dx plus c of y is equal to 0, that is homogeneous second order linear constant coefficients. First of all you have to find, write in operator form. Once in operator form to auxiliary equation. Auxiliary equation is a quadratic equation. Now from quadratic equation find roots. After finding roots, write the general solution. So this is nature of roots. We are having nature of roots, and the depending on nature of roots we have a solution. So first one, real and distinct roots, m1 and m2, real and different, real and distinct roots. Real numbers, the two roots are real numbers, but they are different real numbers. Then what is the general solution? General solution is y is equal to c1 into e power of m1x plus c2 into e power of m2x. m1, m2 are, what are they? m1, m2 are roots of auxiliary equation, roots of an auxiliary equation. Then what is the solution? The solution, that is a general solution, is given by y is equal to c1 into e power of m1x plus c2 into e power of m2x, where m1, m2 are roots, c1, c2 are arbitrary constants. Are you getting? So for real and different roots, this is our solution. Y is equal to c1 into e power of m1x plus c2 into e power of m2x. Now coming to the second case. What is the second? The real and equal roots. The first one is real and different roots. Now the second one is real and equal roots. Real and equal roots. m comma m, both the roots are real numbers and they are equal numbers. M comma m, just like 2 comma 2, 3 comma 3, 10 comma 10, 100 comma 100, like that. M comma m, any two real numbers, they are m comma m, it is a real number and it is repeated twice, that is m comma m, real and equal roots. Once it is real and equal roots, what is our general solution? So second is real and equal roots. In bracket I am writing roots are m comma m, they are real numbers and equal numbers. Then what is the solution? The solution is y is equal to c1 plus c2 into x into e power of mx. So when the two roots are real numbers and equal, then what is the general solution is y is equal to c1 plus c2x into e power of mx. When it is a different, if the two roots are different, real and different, y is equal to c1 into e power of m1x plus c2 into e power of m2x. But when they are equal, then y is equal to c1 plus c2x into e power of mx. Now coming to the complex roots. Complex roots exist in conjugate. If alpha plus I beta is a root, then alpha minus I beta is always a root. So they always exist in a pair. Complex roots, all third roots or complex roots always exist in a pair. If alpha plus I beta is a root, then alpha minus I beta is also a root. Complex roots in bracket I given, you see alpha plus or minus I beta, that is alpha plus I beta is a one root and alpha minus I beta is the second root. So in case of complex roots, what is the general solution? The general solution is y is equal to e power of alpha x into c1 into cos beta x plus c2 into sin beta x. Alpha e power of alpha x, and for beta c1 cos beta x plus c2 into sin beta x. So this is third case when the roots are complex. What is the general solution? The general solution is y is equal to e power of alpha x into c1 cos beta x plus c2 into sin beta x. And in case of sad roots, also they exist in a pair, alpha plus root beta or alpha minus root beta. In that case also similar to this, e power of alpha x into c1 cos h root beta x plus c2 sin h root beta x. In this fourth case does not come in our syllabus. Only first three real and distinct roots, real and equal roots and complex roots. So depending on the roots of axillary equation, that is the nature of roots of axillary equation, whether they are real and distinct, real and equal or complex, depending on that we write the general solution of homogeneous linear second order differential equation with constant coefficients. Are you getting? So simply you have to remember these three formula when the roots are real and different. The solution is y is equal to c1 into e power of m1x plus c2 into e power of m2x, where m1 and m2 are real and different roots. When roots are real and equal, then y is equal to c1 plus c2x into e power of mx, where m is a real and equal root. When the roots are complex roots, alpha plus I beta and alpha minus I beta, then the general solution is y is equal to e power of alpha x into c1 cos beta x plus c2 sin beta x. So this is the main thing of the chapter. Are you getting? So when a general form of homogeneous differential equation is given, so homogeneous means what I mean, it is homogeneous second order linear differential equation with constant coefficient. So once that is given, you can write operator form. From operator form you can write auxiliary equation. You can find the roots of auxiliary equation. Depending on the roots, there may be real and distinct, real and equal or complex. Depending on the roots, the nature of roots, we write a general solution. These three formulas you have to remember. So real and different, this one, first one real and equal, the second one real and complex, then the third one Are you getting? So these three formulas are important. So throughout, now we are going to solve the problems depending on these three formulae. Are you getting? Shall I repeat one more time? Real and different. M1 and M2 are two real and different roots. Then y is equal to C1 into e power of M1x plus C2 into e power of M2x. M comma M are two real and equal roots. Then general solution of y is equal to C1 plus C2x into e power of Mx. And if alpha plus I plus or minus I beta is a pair of complex roots, then general solution is y is equal to e power of alpha x into C1 cos beta x plus C2 sin beta x. Are you getting? So this is what we learned. What is the general form? From a general form, how to write an operator form. What is operator? Capital D. D is equal to d by dx is an operator. So from general form to operator form to auxiliary equation. Auxiliary equation is a quadratic equation. So we can find the roots. We will get two roots. The roots may be real and distinct. If they are real and distinct, the general solution is the first one. If real and equal, the second one general solution. And if the complex roots, it is third one. So you have to remember these three cases. Are you getting? Real and distinct, real and equal, and complex roots. Remember, so that we can go to the problem part of this. So let us move to the problems. So what I said already many times, I said we should cover more problems because many of the students are at home without books, without any material. So let us try to cover more and more problems, all types of problems of the topic, so that you can do any problem on the topic when examination comes, exam point of view. Okay, so what my request is, read these formulas, then practice all problems that we are going to solve here, then try to do the homework. So without practicing, without reading, you don't directly go to the homework. Are you getting? Yes. What is the time left? Yes, another 20 to 25 minutes. So let us try the problems here. So let us go to the problem part of this. Now the first problem of mine is solve. What is our first problem? Is solve d square y by dx square minus 5 into dy by dx plus 6y is equal to 0. You see, right hand side it is 0, therefore it is homogeneous. D square y by dx square term is there, therefore it is second order. And y power is 1, therefore it is linear. And coefficients are 1, minus 5, 6, constant, therefore it is a homogeneous second order linear differential equation. In short, I say it is a homogeneous. So right hand side 0, therefore it is homogeneous differential equation. Now you can write operator form, d square minus 5d plus 6 of y is equal to 0. So then operator form, you can put capital D is equal to m, then you will get an auxiliary equation. So what is an auxiliary equation? M square minus 5m plus 6 is equal to 0. I already told you the working rule. Once a general equation is given, it's a general equation of homogeneous differential equation is given, then try to write in an operator form. Then operator form to auxiliary equation. Then from auxiliary equation find its roots. Depending on the roots, write down the general solution. So now what is an auxiliary equation? M square minus 5m plus 6 is equal to 0. M square minus 5m plus 6 is equal to 0. Now let us to find the factors of this quadratic equation. Now factorize it. So minus 5. If you add them, you have to get minus 5, and if you multiply, you have to get 6. That is minus 3 into minus 2 is 6. Minus 3 plus minus 2 is minus 5. So minus 5m can be written as minus 3m minus 2m. So this is our next step. So m square minus 3m minus 2m plus 6 is equal to 0. Are you getting? So from first two terms, take m common, m into m minus 3. Next two terms, take minus 2 common, then it is minus 2 into m minus 3. So now take m minus 3 common, then the remaining term is m minus 2 is equal to 0. So m minus 3 into m minus 3 into m minus 3 into m minus 2 is equal to 0. Are you getting? What is m? M is equal to 2 comma 3. You got the roots here, you see. Just wait 1 minute. Now, yes. What are the values of m? We got m is equal to 2 comma 3. The roots are real and they are not equal. They are different. They are distinct. So, roots are real and distinct. So, in case of real and distinct, what is the solution? What is the solution? Real and distinct. The first one you see. When the roots are real and distinct, the solution is y is equal to c1 into e power of m1x plus c2 into e power of m2x. We got here, in the first problem what we got? We got it is 2 comma 3. What is the general solution then? Y is equal to c1 into e power of 2x plus y is equal to plus c2 into e power of 3x. Are you getting? This is my general solution because m1 and m2. m1 is 2, m2 is 3. So, if you take vice versa also no problem. The solution is same. If you take first 3, then you write 2, then also it is no problem. Y is equal to c1 into e power of 3x plus c2 into e power of 2x. Any order you can take. Don't worry about the order. First 2, then 3, or first 3, then 2. Both are the same. General solution are the same. So, now we got roots. They are real and distinct. From the roots, you can write the general solution. What is the general solution? Y is equal to c1 into e power of 2x plus c2 into e power of 3x. Are you getting, guys? Are you getting? So, very simple here. I recall you one more time. I am repeating for you. First, a general equation is given. Try to write in operator form to auxiliary equation. Once, excuse me, operator form to auxiliary equation. Once auxiliary equation, you get auxiliary equation, then find the roots. Depending on the roots, if they are real and distinct, or if they are real and equal, or if they are complex roots, depending on the roots, write the general equation, general solution. That's it. This is a problem which comes for 3 marks, and this is a previous problem for 3 marks. Are you getting? Damn sure you get 3 marks question from this. So let us go to the next problem. You see, solve d square y by dx square plus 3 into dy by dx minus 54y is equal to 0, homogeneous, second order, linear, with constant coefficients, everything is same. Now, from given general equation, general form is given, homogeneous differential equation is given, d square y by dx square plus 3 into dy by dx minus 54y is equal to 0. So, what is the auxiliary equation? M square plus 3m minus 54 is equal to 0. If you add, you have to get 3m. If you add, you have to get 3m. If you add, then you have to get 3m, and if you multiply, you have to get minus 54. So 9m minus 6m is 3m, and multiply, you will get 9 into minus 6 is minus 54. So 3m can be written as 9m minus 6m. First two terms, from first two terms, take m common, you will get m into m plus 9, and second two terms, take minus 6 common, you will get m minus 6 into m plus 9. Now take m plus 9 common, m plus 9 is common, m into m minus 6. So m plus 9 into m minus 6. M is equal to minus 9 and m is equal to 6. So again, the roots are real and different. The roots are real and different. Real and different. Then again the first case. What is the general solution? Y is equal to c1 into e power of minus 9x plus c2 into e power of 6x. Vice versa, if you write 6 first, then if you write minus 9, then also no problem. Are getting very easy? This is very easy. You see, auxiliary equation we got m square plus 3m minus 54 equal to 0. Factorization, 3 can be written as 9m minus 6m. So it is m square plus 9m minus 6m minus 54 is equal to 0. Yes, m common, m plus 9 minus 6 common, m plus 9. Now m plus 9 common, m minus 6, m is equal to minus 9 comma 6, and the last one is our general solution. Y is equal to c1 into e power of minus 9x plus c2 into e power of 6x. Are you getting, guys? This is our second problem. Are you getting? General form is given. Try to write an operator form, then an auxiliary equation, solve auxiliary equation, that is factorize auxiliary equation, you get two roots. Excuse me. Once you get the roots, depending on the roots, write the general solution. So the three forms of roots are important: real and different, then the general solution; real and equal, then what is the general solution; complex, then what is the general solution. So depending on the roots, write the general form. That's it. Are you getting? Are you getting the steps? So let us move on to the next problem. The third problem, solve d square minus 25 of y is equal to 0. So given equation is in operator form directly. It is an operator form. No need to write an operator form here. The equation is given in operator form itself. D square minus 25y is equal to 0. Are you getting? So what is an auxiliary equation? At place of d, you have to write m. So what is an auxiliary equation is m square minus 25 is equal to 0. M square is equal to 25. M is equal to plus or minus root 25. Root 25 is 5. So m is equal to plus or minus 5. That is plus 5 comma minus 5 or minus 5 comma plus 5. So you can take any way. Can take any root first and other one second. No problem at all. The order is not problem. Are you getting? So we got the roots. Very simple equation here. You see d square minus 25 of y is equal to 0. Auxiliary equation is m square minus 25 is equal to 0. M square is equal to 25. M is equal to plus or minus 5. No factorization. Directly you got. But this is a previous question. Now what are the roots? Roots are real and different, 5 and minus 5. So again the first case, what is the general solution? Y is equal to c1 into e power of 5x plus c2 into e power of minus 5x. Are you getting? So this is my general solution. So once you got the roots, you can write, depending on the roots, you can write general solution. So don't forget the steps. What are the steps, guys? Given differential equation. If it is a general form, try to write an operator form. Directly third problem is an operator form. Are you getting? The problem may give in operator form directly. So from operator form, substitute at place of d, m and remove y, you get auxiliary equation. Auxiliary equation is a quadratic. Solve it or factorize it to get the two roots. Depending on the roots, what are the roots? Real or indifferent, real and equal or complex. Depending on the roots, use the formulas to write general solution. Very easy. Are you getting? So first three problems we covered, and all these three problems what we got, the two roots are real and distinct, real and different roots. Are you getting? All these three problems are real and different. Now what is the second one? Second one is real and equal. The second case is nature of roots may be real and equal. Now let us go to the second case, that is the two roots of auxiliary equation are real and equal. Real and equal. Yes. Fourth problem. Solve d square y by dx square minus 2 into dy by dx plus y is equal to 0. Homogeneous, second order, linear, constant coefficients, and so on. Blah blah blah. This is a homogeneous differential equation. Are you getting? Operator form. D is equal to capital D is d by dx. Capital D square is D square by dx square. Substitute D square minus 2d plus 1 of y is equal to 0. D square minus 2d plus 1 of y is equal to 0. So general form to operator form. Now operator form to auxiliary equation. Operator form is D square minus 2d plus 1 of y is equal to 0. Now auxiliary equation is m square minus 2m plus 1 is equal to 0. You got auxiliary equation. Now factorize to get the roots. Now factorize to get the roots. What is that? M square minus 2m plus 1 is equal to 0. M square minus 2 into 1 into m, 2ab minus 2ab, 1 can be written as 1 square. So what is that form? M square minus 2ab plus b square. Can you recollect the formula? M square, that is a square minus 2ab plus b square form, that is a minus b all square. What is a here? M. What is b here? 1. So what you get? M minus 1 all square is equal to 0. M minus 1 all square is equal to 0 means m minus 1 into m minus 1 is equal to 0. M minus 1 into m minus 1 equal to 0 means m is equal to 1 comma 1. They are real and equal roots. The second case, two roots, they are real numbers and they are equal. Real and equal. So then what is the general solution? General solution is y is equal to c1 plus c2x to e power of x, e power of 1 into x, that is e power of x. Are you getting? Are you getting, guys? So second case, I want to show you the second case, guys. Wait. So this is our second case. What is our second case, guys? What is our second case? So when the roots are real and equal, what is the general solution? Y is equal to c1 plus c2x into e power of mx. Now in the problem we got m is equal to 1 comma 1, that is c1 plus c2x into e power of 1 into x. 1 into x means x. So this is my problem. This is the problem where the roots are real and equal. The general solution is y is equal to c1 plus c2x into e power of x. Are you getting? Real and equal roots. The first three problems real and different. Now fourth problem is real and equal roots. Real and equal roots. Now let us see the one more problem. Solve d square y by dx square minus 16 into dy by dx plus 64 y is equal to 0. Homogeneous, second order, linear, constant coefficients. Right. Agreed. So this is what given. Homogeneous differential equation given. You have to solve it. So what to do? Operator form. At place of d by dx put d, and at place of d square y by dx square put capital D square. So what is an operator form? D square minus 16d plus 64 of y is equal to 0. And what is an auxiliary equation? At place of d put m square minus 16m plus 64 is equal to 0 in auxiliary equation, which is quadratic equation. Find the roots. Depending on roots, you can write the solution, general solution. So m square minus 16 can be written as 2 into 8m plus 64 can be written as 8 square. So m square, it is m square minus 2 8 into m, 2 into 8 into m plus 8 square is equal to 0. So what is its form? A square minus 2ab plus b square. That is a minus b all square. What is a here? M. And what is b here? 8. So m minus 8 all square. M minus 8 all square means m minus 8 into m minus 8. That is m is equal to 8 comma 8 real and equal roots. 8 comma 8 real and equal roots. Once the roots are real and equal, then what is the general solution? The general solution is y is equal to c1 plus c2x into e power of 8x. In previous it is 1 comma 1. Now it is 8 comma 8. The general solution is y is equal to c1 plus c2x into e power of 8x. Are you getting? So this is the fifth problem we covered. So excuse me guys. So what we covered is first three problems, the roots are real and distinct, and the next two problems are roots are real and equal. Now let us go to the third case, the complex roots. Solve d square minus dx square minus 2 into dy by dx plus 5y is equal to 0. Operator form, d square minus 2d plus 5y, 5 into y is equal to 0. Axillary equation, m square minus 2m plus 5 is equal to 0. You cannot factorize. There are no two numbers whose sum is minus 2 and whose multiplication is 5. So, no factorization comes here. M square minus 2m plus 5 is equal to 0. Factorization is not possible. What is a value? A equal to 1 and b is equal to minus 2. C is equal to, b is equal to minus 2 and c is equal to 5. Now the roots formula is m is equal to minus b plus or minus square root of b square minus 4ac by 2a. Substitute b is equal to minus 2, minus of minus 2, 2 plus or minus b square, that is 2 minus 2 whole square 4 minus 4 into 1 into 5, 20 by 2. 2 plus or minus 4 minus 20 is minus 16 by 2. 2 common. So what happens? 1 plus or minus from among the root. Take 4 common. 4 into 4 you can write. 16 can be written as 4 into 4. 1 4 is, root 4 is 2. Therefore 2 common and cancel. And root 4 is 2. What is the roots are? 1 plus or minus 2i. Complex roots always exist in pairs. 1 plus 2i, 1 minus 2i. So when the roots are complex, then what is the general solution? Y is equal to e power of alpha x into c1 cos beta x plus c2 sin beta x. Here alpha is 1 and beta is 2. So the general solution is e power of x into c1 cos 2x plus c2 sin 2x. So now the roots, the third case, the roots are complex roots are getting here. So m square minus 2m plus 5 is equal to 0. There are no two numbers whose sum is minus 2 and whose product is 5. So we are directly finding the roots by the formula minus b plus or minus square root of b square minus 4ac by 2a. From that you got root 16 means 4, 2 common, cancel, and 2i, 1 plus or minus 2i. Simplification, we got complex roots. Complex roots always exist in pair. 1 plus 2i, 1 minus 2i. Now if alpha plus or minus beta I is the roots, then you know the solution. Similarly, your alpha is 1 and beta is 2. So therefore the solution is y is equal to e power of x into c1 cos 2x plus c2 sin 2x. So this is the third case where the roots are real and distinct. The first case, first three problems, real and equal. The next two problems. Now third case, the complex. The first uncomplex we covered first problem. Now let us go to the second problem. What is given? Solve y double dash plus 16y is equal to 0. Y double dash means y double prime or y double dash is d square y by dx square, another notation. So problem may come in any notation. You have to know all notations. Y double prime or y double dash or y2 or all d square y by dx square. Now write operator form d square plus 16 of y is equal to 0. Now write auxiliary equation m square plus 16 is equal to 0. 16 to this side, m square is equal to minus 16. M is equal to square root of minus 16. Root 16 means 4. Root of minus 1 means I. So I forget to tell you this. Square root of minus 1. Square root of minus 1 is I. In previous problem also we put I. Whenever square root of minus 1 comes, it is a I. Then there is a possibility of complex roots. Remember this. Square root of minus 1. So root 16 is 4. and root of minus 1 is I. So it is plus or minus 4i. So you have to write alpha plus or minus I beta form. So no alpha, that's why write 0. 0 plus or minus 4i. 0 plus or minus 4i. What is alpha? Alpha is equal to 0. Alpha is equal to 0 and beta is equal to 4. Now substitute in general solution e power of 0x into c1 cos 4x plus c2 sin 4x. E power of 0 into x means e power of 0. E power of 0 is 1. E power of 0 is 1. Therefore, what is the general solution? 1 into, therefore, y is equal to c1 into cos 4x plus c2 into sin 4x. So this is what I want to tell here. M square is equal to minus 16. M is equal to square root of minus 16. Root 16 means 4 and root of minus 1 is I. Therefore it is plus or minus 4i. It should be alpha plus or minus I beta. Only plus or minus 4i. So put 0 0 plus or minus 4i. Alpha plus or minus I beta form. Alpha is equal to 0. Beta is equal to 4. Substitute in general form. E power of 0x, that is e power of 0, that is 1. Therefore the general solution is y is equal to c1 into cos 4x plus c2 into sin 4x. Are you getting? So these are the two problems on the third case. Are you getting? So what we are doing, what we did, we given homogeneous differential equation a general form to operator form to auxiliary equation. Once you get auxiliary equation, it is a quadratic equation. So we have two roots for quadratic equation. Depending on the roots, we written a general solution. There are the three cases. What is the first one? Real and distinct roots. When m1 m2 are two real and distinct roots, then general solution is y is equal to c1 into e power of m1x plus c2 into e power of m2x. The second case, real and equal roots. When m comma m are two real and equal roots, then y is equal to c1 plus c2x into e power of mx is a general solution. When the roots are complex roots always exist in pair, alpha plus I beta or alpha minus I beta, that is alpha plus or minus I beta, then general solution is y is equal to e power of alpha x into c1 cos beta x plus c2 sin beta x. So remember that slide, nature of roots and general solution I given in the third slide. If you want, you can take screenshot and by heart that. Only that table gives the answer. So first three problems we covered with the real and distinct roots. Next two problems we covered with the real and equal roots, and the last two problems complex roots. So overall we covered all types of roots, all types of problems on this topic, solving homogeneous differential equation. Now it is time to give homework. So let us try to give homework on homogeneous second order linear differential equation with constant coefficients. So this is my homework, all I given in operator form. If general form also given, directly you can write in operator form. So first one is d square minus 5d plus 4 of 5 is equal to 0. You can factorize. Minus 5 can be written as minus 4 minus 1 multiply 4 you get. So factorization is possible here. So you will get a real and distinct roots. D square plus 60 plus 9 of y is equal to 0. It is 9 means 3 square, 6 means 2 into 3. So d square plus 2 into 3 into d plus 3 square. So a square plus 2ab plus b square type. So a plus b all square. So the second problem comes on real and equal roots. Third one, d square plus 4d plus 13 of y is equal to 0. No factorization, not in a minus b whole square, not in a plus b whole square, no factorization. Therefore, you have to go for formula m is equal to minus p plus or minus square root of b square minus 4ac by 2a form. You will get complex roots. So all the three methods homeworks also. First problem on real and distinct roots, and second problem real and equal roots, and the third problem is on complex roots. Very easy guys, you just remember those three formulas for real and distinct, real and equal and complex roots, how to write the general solution, then you can easily do. So as usual I am saying same thing. First of all, read the concept. read what is the general solution depending on the nature of roots and general solution. Then practice the problems, practice the solved problems. We are covered at about 7 problems. Solve them, practice them. Once you practice them, then try to do the homework. And if you get any doubt in the homework, you can ask for any queries. Mail me naresh.debadi@gmail.com. Are you getting? Or you can post your homework in a Google Classroom also, so that I can respond very quickly and verify the homework. Thank you guys. Thank you. This is the class on homogeneous differential equation. Next we are going to cover higher order homogeneous differential equation tomorrow. Thank you very much. Stay home, stay safe, stay healthy. Thank you.